Bismillahirrahmanirrahim. Assalamualaikum to all students. So now let's continue on the DC analysis when the source is not grounded. So what does that mean by the source is not grounded? This is your source, gate and drain, right? So at your source there is an additional element of RS here. So the first step that you need to do is you need to complete the loop. Why this is important? Because you have a negative supply here and also here is a negative supply. Okay, so how you complete the loop? So here is minus, right? So you have here minus, plus, minus, plus. So how you write? This is 1. And then we go to RG. So here is RG. And then here is your MOSFET. Here is will be your source. And the bottom will be your drain. Your source is connected to your sorry, this is not okay. So your source is connected to your RS and you have another power supply here, so it become minus, plus, minus, plus, and then you connect it to the common ground. So here you're going to write 5 because you already write minus here, right? So you go to the drain and then you have your RD and you have another supply connected to plus, minus, plus, minus, and then this will be connected to common ground. Okay, so what you need to do first, after you label where is your gate, so here's your gate, so this is done. Second, change the circuit to the complete loop, and then what you need to do first is you're going to find the value of your VGS. So where is the VGS? So you're going to label here become plus and minus. So how are you going to get your VGS? What you need to do now, you need to do the loop at your GS loop. So what will be the equation for GS loop? Starting from here, it become 1 plus RG. What is the current flowing to the RG is IG plus VGS plus, so you know that your MOSFET only have one current, right? So RSID minus 5 will be equal to 0. So IG, what is the current for the gate? It will be always 0. Why? Because we have an oxide here. So what will be the equation for your VGS is equal to 4, right? 5 minus 1 minus, what is your RS? 1 KID. So you got here 4 minus 1 KID. So your VGS is an equation. Why equation? Because you don't know the value of your ID yet. Okay? Okay, so when you have the source is not grounded, if you see the previous video, when the source is grounded, you can get the VGS value a number. But since now the source is not grounded, your VGS will be in terms of equation. Okay, so now we go to the second part. What you need to write here, you need to write the word assume. We are going to assume in the saturation. So which formula that you're going to use? ID equal Kn VGS minus VTN squared. Okay, so what is the VGS here? This is your Kn. What is your VGS? Is an equation 4 minus 1 KID and minus VTN squared. Okay, so Kn and VTN will be given. So what is your Kn here? 0.5 milli A over V squared. 4 minus 1 KID minus what is your VTN is 1 squared, right? So you can get here 0.5 milli. 4 minus 1 is 3 minus 1K minus 1 KID squared. Okay, so here will be your ID. You're going to get ID equals 0.5 milli, 3 minus 1 KID squared. So if you see here, you have what we call milli here, and we have 1K here, right? And your ID will be always in milli. So what you need to do now, because this is a quadratic equation, so you're going to drop the milli and you're going to drop the K. So you're going to get ID equals 0.53 minus ID squared. So now rearrange this equation until you got a quadratic equation. So 0.5 you bring here become 2ID equal 3 minus ID, 3 minus ID. Okay, so after you expand the quadratic, you can get the equation ID squared minus 8ID plus 9 equal to 0. Okay, so previously you got one quadratic equation from your ID calculation, and you know your VGS is equal for minus 1K ID. Okay, so by using your equation of your ID quadratic, so use your calculator, you will get ID1 and ID2. So from this ID, how you can calculate back your VGS, use the equation that you got previously here from your VGS loop, and then you will get VGS1 and VGS2. So now we need to know which VGS and which ID that is reliable in this that we are going to choose. Are we going to choose VGS1 or VGS2? So we know that in order for the current to flow, your VGS must be more than 0, right? If VGS is less than 0, it will be cut off. So VGS1 is less than 0, VGS2 is more than 0. So now your VGS1 is actually, your transistor is off. So you cannot use your ID1. So the final answer why you need to choose VGS2. So what is VGS2? It's 2.646 volt, and because it is higher than the threshold, so this part transistor is on, that's why you can get the current. Okay, so what is your final current value? Is 1.354 milliampere. But is it confirmed that this one is saturation? Why? Because just now we assume we want it to be in saturation, right? So what you need to check now? So remember the IV characteristics. So you have here, this is your ID, this is your VDS. So what is the boundary point from the triode? This is triode and this is saturation. So the boundary point here we call VDS set. So next step, what you need to do is to find VDS saturation. So here show how you're going to find your VDS saturation. So VDS saturation is equal to VGS minus VTN. So what is your VGS just now? It is VGS1 or VGS2? You're going to choose VGS2 here. So VGS2 minus your threshold is 1.1. So you got your VDS set equal 1.646. So now after you got the value of VDS set, so you need to have the value of your VDS, right? So in order to do that, you need to have the KVL loop at your DS loop at your output. Why? You need to find the value of your VDS. So now, in order for you to find the value of your VDS, so where is your VDS? It's over here, plus minus. You need to have the KVL at the DS loop. So starting from here, it become minus 5 plus, what is the current flowing through RD is ID plus VDS plus RS ID minus 5 equal to 0. So what will be the value of RD just now? Where is your RD? So your RD is 2 kilo ohm. So here is 2 kilo ohm. Your ID is 1 point. So let's make it here. 1.354 milli. You don't know your VDS. And what is your value of your RS? RS is equal to 1K, 1.354 milli, minus 5 equal to 0. And you can get the value of your VDS. So your VDS is 5.938 volt. Okay. So now what you need to do now? Just now you know your VDS set here is 1 point. Your VDS from DS loop is equal to 5.938 volt. But what is your VDS saturation? The boundary point just now is 1.646 volt. So now, is it your VDS is larger or smaller? So now your VDS now is much more larger than your VDS set. So is it confirmed in saturation? How you know this is in saturation? So this is your graph, right? This is your boundary point. It is much more greater than VDS set. So this area we call saturation. So now, yes, it's correct. So you need to write the word confirm. It is in saturation. So your final value is current is ID 1.354 milliampere, VGS is 2.646 volt, and you can confirm that this value is in saturation. And now you are done with the calculation. So what is the value of ID? Final value is at 1.354 and it is confirmed in saturation. Okay. Okay, so in the self-practice, I give you one self-practice, right? So this is an example again, an example of what we call design equation, problem. What we call design problem. So what you need to do in the design problem, where you need to find the value of unknown resistor. So the steps is the same like what you have learned previously. So it will give you either the value of RTH or R1 plus R2, and it will give you the final value of your current. So what you need to do, you need to do backward, but the step will be the same to find the value of all R1, R2 and RD. So remember, when you do MOSFET, you need to assume, right? So once you write the word assume, you need to confirm whether your assumption is correct or not. So the question will always say confirm any assumption that you make during your analysis. So please try this example and submit after you have done it. If you have any question, please let me know. So that's all for the DC analysis. Thank you so much. Assalamualaikum.